Hello again, everybody, and welcome back. This is the what you can call the appendix to the evening with me and my friends. Due to the Wi-Fi in my house, the broadband went down, and it meant that I wasn't present for the last 40 minutes of the program, and I had quite a lot to still to say. Now, I was talking about the DR5000 at the time that the Wi-Fi packed up, and if you remember, this is, if I get it out of the box, this is what the DR5000 looks like. Quite a small compact unit, and like I said, the only really big shame is that Digicase went bankrupt last week. However, you may still be able to get these, and the person who designed these has started his own company, and the units that he makes look very similar to these, except they're blue. The plastic's blue, and it is yet another model railway company. So it's Yamo RC, is the website that you're looking, and I'll stick a link on there. And he does a very similar DCC controller to this, except it's modular. So you can buy it in multiple parts. The basic unit does your basic DCC, and it's got a certain number of connections on it, and it's got USB and everything else like that. But he does an add-on unit which connects to it and gives, in essence, it gives it all the functions of this. So the only other real thing that I have to say about this particular unit, and I'm sure that the new ones will also conform to this. This is the power supply that you get with it. It's a standard it's a maximum of 20 volts at 4.5 amps, but it can go up to 24 volts at 90 watts, so you'll have to work out it. Obviously the current reduces as you increase the voltage. But the very useful thing about this particular power supply, which you should be able to see this, the output voltage is selectable, and if you can see, my switch is set to 16 volts for this, and I've had very good results running with it at 16 volts. My other unit that I showed you earlier, the Pysprog, runs at 15 volts, and that's fine for the micro layout. It's not a big problem. Obviously, if you've got a huge layout or a larger layout, you will suffer a certain amount of voltage drop if you've not used the optimum size of wire. So there are various guides available on the internet that you can see where they tell you what wire to use according to the current, but really you should be using the thickest wire that you've got. Certainly solid wire conducts better, so just standard twin and earth is quite good if you've got a large layout. That would be my opinion. The small railway upstairs, I use 55/0.1 because it's extra flexible, but that will carry 6 amps, and there's 2402 and 3202, which are the larger gauges of domestic wire that you can buy from places like Rapid and Amazon, etc. And if you've got a largish layout, that is the kind of wire that you should be thinking about. So I've said the DR5000. If I apply my 5 questions to the DR5000, am I happy with it? Yes, I'm extremely happy with it. Its flexibility is without comparison. If you want to buy stuff from other manufacturers like throttles and things like that, it will accept virtually anything. It generates its own Wi-Fi network. It's got Bluetooth. It's not got Bluetooth. It's got USB. It's got its own separate programming track output. Modules are available, and there's cross compatibility, even though they've gone bankrupt with these new Yamaha RC modules. So would I change anything about it? Well, about the only thing that I would change about it, if I had the power to do so, was that I would wish the manufacturer hadn't gone bankrupt. But I've got no control over that. But I will still use this unit when I get to build my large layout. So moving on ever so slightly, so we've got another unit which I mentioned right at the beginning of the program, and this is the Merg unit. So it consists of a number of modules. So there's 4 modules in this, and like I said, it's about £100 or so plus your Merg membership. But that's just for the boards. If you want the case and posh connectors for it, like I've fitted to this, these are just standard connectors from Amazon. Again, if you want all the add-on bits, obviously it's going to cost you a little bit more, but it's still going to be cheaper than buying a manufactured unit if you can live with making it yourself. The instructions, the Merg instructions, are extremely good. They are step by step. Do this, do this. These are the components you want. All the components are really well identified. There's testing. You do the testing in steps. So you do the testing without all the integrated circuits fitted, just to make sure it doesn't go fut like the booster did when I made it. It was, if I remember at the start, it was this capacitor here, that one, that I put in the wrong way round and caused Boris to go into orbit. But you know, that was my own fault. I was just rushing. So what you have in effect is you have the DCC control unit at the top, and what I've done with this is I've connected it so that it just does the programming track. So I've got this unit has got a separate programming track, but what you can do with it, there is an output over here. This is the main output, and I've routed that down to the booster, which sits underneath. The booster is being redesigned at the moment. These are the old ones. This is the NB1N or NB1B or whatever it was called. This was the standard Merg booster, and you can make this in 2 versions. All depends on what power supply you can get for it. But I've got a 6 amp 15 volt power supply upstairs, which I've made 2 of these, and I've got 1 kit still to make. This one is set up to run at nominally 5 amps, but you can, with the same components, make it run at 10. You just need more substantial heat sinks for these transistors. Well, they're field effect transistors. So one of them controls the input to the unit, the power input to the unit, and the other 4 are what do the driving. So if you want to make this as a 10 amp unit, there are a few resistor changes. These resistors down here, which you can see by my finger, they change different values, and you have to have more substantial heat sinks. But apart from that, it is quite easy to build. Well, it's a little bit unfair me saying that it's quite easy to build, because I've got 30 years experience in manufacturing stuff. If you have got reasonable soldering techniques and the correct equipment, the soldering techniques for electronics slightly different from building kits, and you have a little bit of a challenge nowadays, because unless you can get traditional 60/40 lead tin or tin lead solder, the modern solder, you need extra flux, and I use surface mount flux, which is non-corrosive, and I can wash it off with water if I want to. But I assembled all this with surface mount solder, use the flux on all the connections, and as long as you do it carefully, it doesn't affect the PCBs. It makes a good joint. It makes a better joint than just using the solder by itself. What you get in the kit, it's, although it looks like there's 4 boards, there's actually 3 kits. So this board down here, this is the connection board where your throttles plug in. I couldn't be bothered to cut a square hole, so I just cut circular holes to coincide with where they're going to be. So you get one of those kits included with the controller, and basically it's C-bus, it's Merg C-bus. So what you have is you have a twisted pair of wires, which I'll see if I can. So down here you can probably see those green wires, and over here on this side you can see the orange or brown wires down below. What I've done is I've just taken those out, some Cat 6 cable, and they're supposed to be twisted to eliminate interference. That forms a bus, and it's terminated on this board, and it also goes to this, the USB adapter. And the other wires are 0 and 12. So you've just got to run that around. A lot of people who make these, they just bolt them to a bit of wood, or they use some standoffs. I mean, I used some standoffs because I couldn't quite get all the boards in with the connectors. Now I could have replaced the connectors with something else, but I made them as they were intended, and so that's why the control unit is sitting up, so it's quite a deep box. And the other thing I've done is that the LEDs are normally mounted on the boards. Well, if it's in an enclosure, it's not much use, because if something goes wrong you can't see. So all the ones that it's necessary to see outside. So this one is the orange, that shows the track alive. This one is track alive, and these ones are obviously power applied. Bit of a strange one that they're the wrong way round, and trip, and it works fine. It works really well, this unit does. The cab, the handheld unit, as I mentioned at the beginning, this is the handheld unit, and there are 2 versions of this. You can get a version, this one is the one with a pot, a potentiometer, a variable resistor. So this control is a variable resistor. You can get it with a digital encoder as well, and I mean, I got this one because I'd been waiting 5 months for this to become available, and I got the first one and this was the first type available. So it lights up, and it's got all the standard controls of a normal DCC unit. It's got all the functions and everything else like that. You can consist. It's got an emergency stop. The only difficult thing about making the Merg system, if you're not completely happy with your own soldering skills, is soldering the display. The display uses 1mm connections rather than 0.1 inch connections, which is 2.54mm. The 1mm connections are extremely tricky. Well, I found them pretty tricky even for my, excuse the expanded head, my level of skill. I found them quite difficult to solder, but it is catered for in the kit because it's been acknowledged that there is a bit of a difficulty doing this. So what they've done, they supply you with a bit of desolder braid, which you might have seen. It's basically a copper braid about that wide with powdered flux in it, and what you do is you apply it to the joint and then apply the soldering iron to the braid, and then what it does is it wicks up any excess solder, and I had to use that twice, but they give you a length about 2 inches long, and that's perfectly adequate if you've got good soldering skills. So that is all the DCC equipment. I'll just show you, I did say I made 2 boosters. This is the other one. This is a 5 amp booster. I've put all the LEDs on the outside, and this one works really well. It's got a 5-pin input which collects various things, and it has got a 4-pin output, one to a meter. I can have a meter on this if I want an external current meter. 2 connections for the track, and the other thing I did is, because the box is a lot smaller, I fitted a 5-volt fan. I had some 5-volt fans left over from making all the Raspberry Pi assemblies that I've made, and I just put one in. It meant I had to put a heatsink on the 5-volt regulator, but it does help. And if you're worried about it, you can add a thermal cutout to the unit. There's provision for a thermal cutout. Reading through the questions, one question was asked. I can't remember who it was by, but if I can address that question, the question was, how secure is the Wi-Fi function on all these things? And John mentioned Wi-Fi, I mentioned Wi-Fi, Julian mentioned Wi-Fi, and you can use various Wi-Fi devices. Most of these modern DCC controllers that you buy have the provision to add Wi-Fi cabs. Security on the Wi-Fi, well, it is as secure as your home network is, so you would expect your home network to be relatively secure. You have to enter a password to get access to your Wi-Fi, so it should be secure. It's as secure as your home network. The other thing is that if you do what I do with this unit, the small PiSprog unit, and the DR5000, where I use a Raspberry Pi, and the Raspberry Pi is capable of creating its own Wi-Fi network. Well, the thing about that is you create the Wi-Fi network in Panel Pro in JMRI, and you can give it whatever address you want. I mean, I won't go into a huge explanation of how TCP/IP works, which is the standard internet protocol, but there are 2 methods of connecting to what is a TCP/IP network. Normally when you connect to, say, your house router, it will use something called DHCP, which is a dynamic protocol. So what your router has got, it's got a table in it which says, I am such and such a device, but the last digit is a 1. That means that I'm the gateway. So all the other devices have to be between 2 and 255, so you can have 253 devices basically, but you can have more, but I won't, like I said, I won't go into huge details about how it works. So when you turn on a device that is TCP/IP compatible, like a small tablet or your phone or a laptop even, or anything else like that, what it does is it goes to the machine and it says, right, I am a TCP/IP device, and I am set to DHCP, please give me an address. And the router will give them address. It can give them an address at random, or it can give the next available one. Sometimes it will remember. So when you turn a device off, for example, and then reconnect it to the network, it will give it the same address. But it's dynamic, so as long as it conforms to the 2 to 255 specification, then that's it. It's quite simplistic to describe that, but like I said, I'm not going to go into big detail about it. The other thing that you can do, certainly with JMRI, is you can tell the device that is providing the Wi-Fi network, and it was in the settings for the DR5000. So you can go in there and you can do something. You can give it a static address, not a dynamic address. So static address is what it sounds like. So it will be a fixed address. And what I do is I program the Raspberry Pi to give it a static address which is different to the house Wi-Fi. So it will create its own Wi-Fi network, but it will be different to the house one. It'll have a different number, but it is still, the last digit is still number 1, because that's the gateway, that's what you want to connect to. So of course, if you can give the Raspberry Pi a different address, you can give things like this a different address. So all you need to do to get the security is to make sure that the first three groups of digits are the same between what you're connecting and what you want to connect to. So there is a convention, although you can call them whatever you like. The first 2 sets of digits, and if you remember, it's all hexadecimal. It's a decimal translation of a hexadecimal number. So there's 4 groups, and they all go from 0 to 255. And for the standard, there's 2 standards for a local network, and the most common one for the first 2 digits are 192.168. What you call the next 2 is entirely up to the device, or up to you if you want to do it. So when I program the Raspberry Pi, I call it 192.168.4.1, and that is the address. It's the gateway address for that device. The house network is completely different. So if I program this with a static address, which the first 3 groups of digits are the same, and the last digit is not a 1, or it's a 2, or something like that, then this will just connect to that piece of kit. And it's the same security, because if you think about it, you've got sort of umpteen possibilities. Well, you've got 255 times 253 possibilities, which is quite a large number. So the odds of someone breaking into that network is not all that likely. So you can configure your own static network and just have those on it. I mean, if you want to make it public, then you can, and you can have people dialing in and operating your trains. Just before I put this away again, this is just a standard cheapo tablet. It's not particularly fast, and it wasn't very much money when I bought it. So, and this is what I use as throttle. So there's an app here. I hate calling them apps. I'm used to calling them programs. But there's an app here called Engine Driver. This is an Android tablet, and when you start it up, let's try and get it the right way up. It basically opens this, and if you can see down here, what it's done is got a couple of networks programmed into it, or links. If you see that top one where it says my JMRI network, if you can see above that, there is an IP address 192.168.6.1. Well, that's the IP address. I said 4.1, but it's 6.1, and that is what it connects to when I've got the PySprog running on upstairs. Obviously I can't do it here, but the other thing that I've got at the bottom, if you see what it says JMRI SteveTodd.com. Well, Steve Todd was the guy who actually made the sketch for the Raspberry Pi for doing JMRI on an Raspberry Pi. All the work is done for you. So if you follow the instructions on the JMR website for creating a Raspberry Pi iteration of JMRI, it's his software, and you can freely use it, and it's quite easy. It takes about 20 minutes to do it, and it downloads onto a SD card. But if you can see at the bottom, that is the simulated one. Now if I click on that, what it's done is it opens up Engine Driver. Sorry, there's a lot of reflections from the I'm sitting next to the dining room window. Hold on. Right, so that is what Engine Driver looks like. You've got forward stop, which is an emergency stop, and reverse. These are all your functions. You've got select, and you can select the locomotive and everything, the address, and this slider along here is the throttle. I quite like it. It's okay, but I'm angling towards buying a Wi-Fi enabled throttle, which loads on the market, which you can buy, and they vary in price, but I'm seriously thinking about buying one. Can't quite justify it at the moment, but when the larger layout outside gets going, I will probably buy one to go with that. So that's Engine Driver, and if you're Apple inclined, there are apps for iPhones and iPads that which you can use. So I can't get rid of it at the moment. So Well, I can't. So it won't let me. Oh, there it goes. Right. So I've cleared it down. So I haven't. This is one thing that you need to do if you're not familiar with the way that all kinds of tablets work. If you shut the app down on the tablet, it doesn't actually shut down. You have to go into the what's running by background and then flick them away. Same with Apple to actually stop them. So now if you click on that square button down the bottom, there's nothing running, whereas before there were two apps still running even though they weren't running. So I'll shut that down and get rid of it. The other thing that I wanted to talk about, or there were two other things that I wanted to talk about, other control methods, two other control methods, one of which was radio control and the other one is direct Bluetooth. So radio control, I tried to get someone on to speak about this, but no one was particularly willing to come on and speak about it. But there's a video, if you watch the video shortly, that is Graham Powell's Wi-Fi network. It's out in his garden. All he does, he charges the batteries. The batteries are in the leading coach and they power the locomotive, and he just uses a standard radio control unit. And there are various suppliers who will supply the necessary controllers to do that, control that. I'll give my and it has its great advantages. There's dead rail. There's no rail in the power. No rail power. The power is in the carriage. It's batteries. ABC, who made the gearboxes, the motor assemblies, I don't know if they still do it, but they were reducing their range. But they made 6-volt versions specifically for this radio control protocol, and it is pretty easy to do. There's loads of resources available. It's quite a mature technology, and if you want to make a personal radio control layout in your garden, you don't have to worry about keeping the rails clean, because there's no pickup of the power from the rails. So one of the big advantages of doing radio control is that it is self-contained. I will put there are some links that Stephen said that he was looking forward to me talking about it, but I'm afraid, Stephen, I can't talk about it because I've never done it. All I can go on is what I've seen and what other people have done, and you provided the resources to do this. So there's a couple of Facebook groups that are worth looking at, and there are some other groups which you can hunt around for, who will help you. The only thing that I can say is, if you want to pursue this, doing this, is to find out someone who's done it and get as much advice as you could from them. So if you're thinking about doing it, get some advice. Use the forum if you're that way inclined, or find out from other people who's done it, and as they've done it, they're in a better position to advise you than I could ever be. The final thing that I wanted to talk about in this appendix to the evening with is direct Bluetooth, which is sort of like a relatively new technology, although there are a couple of American suppliers, one of which is Bluenami, which you can search for on the internet, and they make some quite powerful controllers, 2.5 and 4.5 amp controllers. They go directly in your locomotive and you control them with an app on your phone. There's only one slight downside to this. If you are not an Apple person, there is no Android app yet for controlling these Bluenami controllers. The other downside is that they're quite expensive, but then when you weigh up how much these controllers cost against having a DCC setup, they're about £200 or 160 odd pounds for a decoder. They have their advantages and they have their disadvantages. One of the advantages is that you don't need to rely on the locomotive picking up the DCC signal. The DCC signal is transmitted directly to it. So you can have batteries to power it. You would have to look quite closely into that, and I'll come on to powering them by batteries again in a moment. Have to look closely at how you were going to do this if you want to use batteries, but otherwise you can just power it with a flat 12 to 15 volt supply, and again you have to be a little bit careful about the voltage supply as well. There is a sort of a more budget range of these Bluenami controllers or direct Bluetooth controllers coming out under the Hammett & Morgan Hornby sort of umbrella, and they are only just coming out now. That I've seen some posts from people who've had them and use them, and some of them find them very good and some of them find them not so good. What you have is you have, and again there's only an iPhone, iPad app for it. It said that it would work on an iPod, and I've got one of the last iPods that was made, and it said that it was compatible, but I couldn't get it to work on my iPod, whereas other iPhone and iPad apps do work on it. So, but I couldn't get it to work. The chips and everything are considerably cheaper, but they are limited to what you would expect necessary to drive a double O locomotive. Now that's all very well and good if you want to put it into something with an efficient motor gearbox. You might get away with it. I don't know if you can use some of the, for example, oh, it's gone out of my head. The company that makes the sound decoders. Oh, it's gone at the moment. I'll remember it in a minute. But they make an adapter board that you can plug a 21 pin double O controller in, and what it has a driver on board, so it increases the output current to the motor. So I don't know whether it is whether that would work. I wouldn't try it. I wouldn't have tried it. The other thing that they do is they do a USB to ExpressNet adapter, a dongle, and I've ordered one of these dongles, but it's not due out until the end of this month, and I bought it to try it out, to see if I can use a direct Bluetooth app using the DR5000. The DR5000 has an ExpressNet port. It's this one here where it says XN. It's an ExpressNet port. So I will try that. Failing that, I've got yet another DCC controller in the other room, back from when my boys were younger. I've got a Hornby Select, which is programmed to the latest firmware. I haven't bought that one out and showed it because there are question marks about whether the Hornby Select is NMRA compliant, and well, I didn't want to bring that out and get shouted at, so I've not brought it out. People have said that they've had problems with the HM7000 kit, and that has largely been down to what power supplies they've used. If you use any form of PWN controller, so that's a pulse width modulation control, so this is, for example, say you've got a DCC system, the signal out of a DCC controller driver is in effect a PWM signal. It's not a flat line or with a little bit of ripple in it. It is a square wave going from 0 or just above 0 to whatever your track voltage is. They have found that if you use a PWM supply, it will fry the decoder. Simple as that. It will fry it virtually universally. It will fry the decoder. The decoder will only work with straight DC. So that's either battery in an adjacent vehicle or 12 to 15 volts on the rails. If you do decide to do Bluetooth DCC and you're thinking about doing a battery supply, it needs to be at least 12 volts. It's not like the radio control one where you can use a lower voltage. It has to be at least 12 volts, 12 to 15 volts. So that will make your battery pack reasonably bulky if you want it to last a length of time. Other advantages is because it's direct Bluetooth, you can do things to the decoder that you couldn't normally do with an ordinary DCC controller. You can do things like take your DCC controller out of a steam locomotive, put it in a diesel locomotive, and if you have a sound equipped direct Bluetooth decoder, you can reprogram it on the fly from your phone. So it's got a diesel sound on it, look a bit strange having a class 66 sound file in a Flying Scotsman and A3. So what you can do is from your phone you can change the sound file. You download the sound file to your phone and then use the sound file from your phone, upload it to the DCC decoder from your phone, and all the functions change and your A3 now sounds like an A3. There are more and more sound files becoming available, and if you did that on a standard DCC controller, you would need a specialist piece of kit to do the programming. So like most things, there are advantages and there are disadvantages as well. I would say that if you were really thinking about doing this seriously, I would wait maybe another 6 to 12 months to let the technology, especially if you want to do it on a budget using the Hammett and Morgan equipment, or try to do it on a budget using the Hammett and Morgan equipment, because they're never ever going to drive a Helljan class 37, for example. You need about 5 decoders for the capability to do that. But if you've got something that's running using a Canon 1833, for example, there you may be able to do it. Although I haven't been able to find any current specifications for the motor output, but like I said, it would be along the lines of what's available and what's required for a 00 locomotive. So maybe a maximum of 1 amp or 1.2 amps maybe with an overload, may even be less than that because they do N-gauge and 001s, which are slightly different. But the chief advantages is cost. The Blue Army controllers are, like I said, £160 upwards. Your bog standard sound decoder from, say, someone like YouTube's, who I use, you're looking at £120–130 with the speaker. More if you want to add a stay alive, a specialist stay alive. These come in at about £60–65 for a sound controller. If you check out the latest adverts in something like the Railway Modeler, for example, they'll give you an idea of how it is. And the Bluetooth dongle that I mentioned, that is £40. So it's worth trying. If it works, it great. If it doesn't work, it's not a huge amount of thing, and I would probably be able to sell it again along with the Select, because it will definitely work with the Select. It might not work with the DR5000. So that is about that. All I can do at this juncture is to basically say sorry that my Wi-Fi failed. We get our broadband from Virgin Media, and the reliability over the last couple of weeks has been poor, basically. And I could go elsewhere, but the thing is that my download and upload speeds are very high. Download speed's about 500 megabits per second offhand, and the upload is getting on for 50, which is perfect for all the other video work, you know, the YouTube channel and everything, and doing this. So if I went for another supplier, I don't think I would get the inclusive deal that I'm getting now, but I apologise. It is what it is, and I'm very grateful for all of you who watched the original program, and all of you took part as my guests for keeping it going for as long as you did. So thank you for taking part in the original program, if you did, and thank you for watching this. And I hope that what I've tried to get across has been useful and been thought-provoking, and has given you some ideas about what options are available for layout control. It's one of those subjects that I could never have covered in 6 of these evenings, because it is so diverse, and well, that's all I can say. It's something that you could never have a hope of covering it in any detail, but I hope I've given you a point to start. And if you've got any further questions, submit them by the forum if you're a guild member, and I'll see what I can do about answering. So thank you for watching, and watch for all the other things that are coming on in the guild. There'll be a little bit of an advert after this, so make sure that you watch out for all the other things that happen. And if you see me around at an exhibition festooned with camera equipment, say hello. I won't bite your head off. Bye bye.